Okay, so how do I recognize direct variation when they give me a graph, table, or some equations? So what do you need to consider so that you can recognize direct variation based on the representation they gave you? So if you have a graph, the first thing you want to look for is it linear. That is a straight line. So it is linear. Check. Okay. Also, you want to check to see that it passes through the origin, meaning the y-intercept is 0. So we're going to check to see, is our y-intercept 0 in our graph line? Yes, it is. It starts at 0 and then it moves up and to the right. Now, I do not have to calculate the slope to know that that slope, that constant of proportionality is constant. Being linear tells you that that ratio is constant. I just have to also check that it passes through the origin. And because both of these things are happening in my graph picture, yes, this is direct variation. It's a very simple checklist. You just got to remember that checklist. Linear and passes through the origin. Okay, what about a table? Guys, a table is not going to be as easy to determine as a graph line is, and here is why. You may not have the y-intercept point in your table, so you cannot assume that it is not passing through the origin. It just may not be one of the points it's selected off the graph line. So how do you tell it's direct variation? Well, you're going to have to actually calculate your constant of proportionality. You're going to have to do a little bit more math to determine if it is passing through the origin or not, if it is direct variation. Okay, so here's what we're going to do. We're going to check to see if the ratio is constant, okay? That's going to tell me if it's linear. If it's not linear, I don't even need to bother seeing if it passes through the origin because it's already failed the first test. It has to be linear and that ratio has to be constant. And to get the constant proportionality, all I need is one y value and one x value, one ordered pair. That's it. I have 4 options in this table. So I'm going to pick an option. I'm going to pick a y value, and I'm going to use, let's use 185. So 185. If I use the y value of 185, I have to use its input pair, which is 4. And now I'm going to get my calculator, cleared the memory, and now I'm going to do the math. So I'm going to type it in, and I'm going to do 185 divided by 4. And I'm not going to worry about a fraction, and here's why. I'm not graphing it, so I don't need which 2 numbers for a direction. I just want to see compared decimals, because sometimes fractions are hard to see if they are equivalent, and the only way I can tell that is by looking at their decimal value. So this tells me that 185 divided by 4 is 46.25, 46.25, 46 and 25 hundredths. Now, I want to see if this ratio is constant. So what I'm going to do again is I'm going to find K again. But this time, I'm going to pick a completely different x and y value and see if I get 46 and 25 hundredths. Okay, so what x and y value do I want to pick? I'm going to go with, let's do 325. And because I picked that output value, I have to use the 8 as my input. And now I'm going to do the math in my calculator. So I'm going to clear my calculator and I'm going to do 325 divided by 8. And that tells me it is 46 and 625 thousandths. So 40 and 625 thousandths. Well, do those look the same to you? Do those look constant? That would be a no. So they are not constant. Therefore, this is not linear. And I can stop right there and I can say, no, not direct variation. Which means this graph line of this table has a curve to it. It is not a straight line because it's not a constant slope. Okay, so what if I have equations? How am I going to tell from an equation that it is direct variation? Well, remember, direct variation is just a y equals mx plus b where the b is 0, which is why you don't see it. So it's really y equals mx. Okay, so I have y equals mx. I have x squared. So first thing I'm going to do is I'm going to use my calculator and I'm going to check to see, since it's in y equals, I can type it in my y equals screen, and I want to check to see, is it linear? X to the power of 2. And I'm going to hit graph so I can see a graph picture. And I'm looking at my graph picture here, and that is not a straight line. So I'm going to say not linear, which tells me this is not direct variation. And for sake of saving space, I'm going to abbreviate DV for direct variation. So it's not linear, it cannot be direct variation. All right, moving on to the next. Again, I have to see if it's in y equals mx plus b format. So I'm going to rearrange 3y equals. I'm going to move my 2x to the other side. So I'm going to have 0 minus 2x. But do I have to show the 0? No, that's going to be a negative 2x. And then I'm going to divide by 3 on both sides. And I'm going to get y equals negative 2/3 x. Okay, so again, I have this equation. I don't see a b, which tells me it's 0. And I have a slope of negative 2/3. So if I want to check to see if it's linear, all I have to do is go to my calculator and go back to y equals, hit clear, and I'm going to type in my fraction, negative 2/3 x. And I'm going to hit graph. And that looks linear to me, and it looks like it passes through the origin. I can also go to the table to check to see if 0, 0 is in one of the ordered pairs to make that graph line, and it is, which tells me that this is direct variation. I'm going to put a check above it. Okay, let's look at the next one. It's already in y equals format, and I can see very clearly that I have a slope of 1/2 x. I don't have a b, which tells me that the b value is 0. So let's go ahead and type this in our calculator. Go to y equals, and I'm going to clear that out, and I'm going to type in 1/2 x. And I'm going to hit graph, and I want to see, is this a straight line? Oh, hit graph. And that looks like a straight line to me, and it does look to pass the origin. I can double check by going to my table and seeing 0, 0 is in the table of ordered pairs, so that does fall on the graph line. So yes, this is direct variation. All right, for the last equation, again, I'm going to have to rearrange. So I'm going to have 6y equals 30 minus 5x, because I'm going to subtract 5x from both sides, and I'm going to divide by 6 all the way across. I'm going to get y equals 5 minus 5/6 x. Okay, so I noticed right off the bat I'm in y equals mx plus b format. But I noticed that I have a y-intercept, so I'm going to double check again to make sure that it's linear. So I'm going to type in 5 minus, now I'm going to type in 5/6 x, and I'm going to hit graph. Okay. And if you notice, yes, it is linear, but it also has to pass through the origin. This does not pass through the origin, which tells me that this is not direct variation. So I'm going to put an X above this one. It's linear, but it's not going to pass through the origin. So now that I know which two are direct variation, these slopes are going to not be called slopes anymore. They are going to be called constant of proportionality, because these are special y equals mx plus b equations. That's what direct variation is.